Hi everyone, today let's look at the LeetCode problem 347. Top k frequent elements. Given an integer array, nums and an integer k, return the k most frequent elements. So what this means is 1 is the most frequent element and 2 is the second most frequent element. So we will have to at least give the top two frequent elements here. So that's the quest. And you may return the answer in any order. So order is not a problem. You will either return it as 2, 1 or 1, 2. Now let's look at the intuition of how to solve this problem. Now let's take an example. Nums equal to 1, 1, 1, 2, 2, 3 and our k is 2. We'll have 3 instances here, 2 instances here and 1. So that means our output will be 1, 2. Let's see how to solve this problem in an optimized way. We first take a hash table, and in this hash table we will identify each of these unique elements and the frequency of these elements in the array. We will have 1 which will occur 3 times, 2 will be 2 times, and finally 3 will be 1 time. So that is the content of the hash table. This will give us the frequency distribution of the numbers. From this we have to take the k most occurring elements. How can we do that? That's where we could use a min heap. We will maintain that min heap for size 2. At any given point, we only need the k most frequent occurring elements. Let me explain with this example itself. This is a min heap. Okay. Now we'll iterate through this frequency table. And so first we'll put 1, 3. And we will sort it based on the frequency. So this is 3, 1. Then next what will happen? 2, 2. So 2 instances are there. So it will come here. Next what will happen is we will have 2, 3, 1. 1 instance of 3. This value doesn't have any significance because we just need 2 most frequently occurring elements. If we just finally populate the contents of min heap, then that should give us the result. So this we will need order of n to construct. That will be the time complexity. For this, we have to iterate through this n elements, and heap is maintained at k. So each insertion or deletion is going to be a log k. So that means this will be order of n log k. So that means the overall time complexity will be order of n log k. With respect to space complexity, for this hash map, we will need order of n, and then we will need a size k min heap. So that will be order of k. Space complexity is order of n plus k. I hope this is clear. Now let's code this up. First we will have an unordered map which will store the number of instances of each unique element in nums. So this will be num count. Then we'll also have a priority queue which will be the min heap basically to finally identify the k most frequent elements. So for that I'm also just keeping an alias just to make it more readable. So we'll just use parent for pair int comma int. Just for our understanding, this pair will be storing data in the form of frequency of the number comma number. So this will become the min heap that we need for keeping track of the k frequent elements. Then we will iterate through the array to identify the distribution or the frequency. Now you have the frequency of all the elements in the array. Next step will be construct that k-sized min heap. So we'll just iterate through the map now. We've pushed the frequency first because we want it sorted based on the frequency. And if min heap dot size is greater than k, we can remove the top of the heap because there is no point in having a value which is less than k frequencies. That should take care of this. Then finally we'll construct the output. We'll iterate through the heap and we will create the list. We will iterate until the min heap is not empty, and we'll just push the number in that min heap element into this output parameter and keep deleting the top. I think this looks good. Should be push. Okay, so this looks good. Thank you. Have a good one.